Okay, while our technical staff is getting things ready, we'll get started here. The session is called the Augsburg Experience. It's different from the rest of the sessions. McAllister is presenting what McAllister did as an institution, etc. What we're doing here is not talking about what Augsburg is doing as an institution. It's pretty typical quantitative reasoning requirement, a number of courses satisfied across the curriculum. We just moved from a single course to 2 levels called quantitative foundation and quantitative application. The difference being an application is one where the students do a project of some sort. So that's kind of the institutional stage at which we're at. What we're presenting here are some attempts to develop instruments. Because I noticed in reading through the people coming, one of the things we want to do is to assess or diagnose, depending on how you're using the terms. And we've been at this for quite a while at Augsburg. We did an international comparison of statistical. I use the term statistical literacy, but at this level, they're all interchangeable. Nobody knows what any of them are anyway. So we did an international comparison, and we also did it by level. We did it with students, we did it with faculty, and we did it with researchers, people that are in the field using statistics. And yet, we come from a literacy tradition. If you take Carl, you say they come from an argument tradition. We come from a literacy tradition. Other people may come from a math tradition. So we started a lot with words, tables, graphs, pretty basic stuff. And we found that the error rates were much higher than we expected, and there wasn't that much improvement with education. There wasn't that much improvement with education. In fact, this is the only survey I know that actually surveyed the editors of the U.S. Statistical Abstract on their ability to read the tables in the U.S. Statistical Abstract. And the guy's a friend of mine. He said, "No, you're never going to publish our data separately, are you?" I said, "I wouldn't think of it. But I'll certainly tell the story of how you didn't read one of your own tables." He said, "That's fair game." I said, "I'm an editor. I don't have to read everything, but I assumed I understand what my own table said." So what we're doing here is presenting 2 different attempts at assessing students' ability to read, understand, and in Marc's case, to write. Because that's the bottom line, the ability to communicate. Numerical data presented, tables, graphs, and in words. So it's a pretty confined area. But we really believe this is a crucial part of literacy, quantitative literacy. I figure the most important thing I would take away from a session like this is Carlton's observation. Carlton's students don't use numbers when they should, and that's a fact. I think that's the most important fact that we're dealing with. Students don't do what we would like them to do when they have the data there. It's paper-clipped, it's stapled, it's attached, pasted into their document, but they don't reference it in their writing and their argumentation. That to me is the #1 fact that other faculty need to be told about. And now if you want to say our students are better than Carlton's, you make that argument. I can't, okay? But the mind immediately goes to why? Why don't they do this? And let's think of good reasons. They're journalists, political scientists. They don't want to get bogged down in minutia, and so you don't want to stop for numbers. You just want to say it's bigger, many, most. It's a way of keeping an argument flowing. And if that were the reason, we could cut some slack for it. But if, on the other hand, the reason is they can't do it, we want to know that. We're taking the tack. We want to see what they can do when they're instructed to do things. So my colleague here, Marc Isaacson, is going to prepare a beautiful little case study where you take something published by the government, designed for consumers. You ask students, here, read this data, answer these questions. Marc Isaacson, Augsburg College.
And a handout should be coming around that give you the original source document. You know, this is a Census Bureau quick facts brochure, kind of the consumer summary. There's obviously there's a 168-page detailed explanation of what they did, how they did it, and not something that the average person is going to read. But the details are published. But my goal is to pick something that would be accessible to college students. In my case, I use this, originally created it for a class that I teach called Statistical Literacy for Managers, which is a variation. We teach some statistics, but also a focus on reading and writing and interpreting or communication of statistics. And so that fit there. But I also teach a course in Management Information Systems in the Business Department, which is a first or second year course where students, they learn some spreadsheet skills, they learn some math. It's in our new Gen Ed system, it's a quantitative foundations course that then prepares them to go on to a quantitative applications course. And when you're using a spreadsheet, common tasks are to create charts and tables and graphs and give you this data and you do stuff with it. And mechanically, the students were able to do a fairly good job at it. If the book said, well, do these 12 steps, they could turn the data that was given them to them into a pie chart. But if you ask them to read it, or if you ask them to create a pie chart that says this, it's a whole other question. And so we'll see some of that here in a second. And so I did this, the numbers we'll see in the summaries as far as the results. I did this as an activity with a pair of undergrads. So the undergrad numbers are actually two students working together. So presumably if they're working, two heads should be better than one. We'd expect the numbers to be better, but we'll see that. And I also, I teach an MBA course in quantitative decision making, and in one of our sessions I gave them this activity. They did it individually, so we had 11 students that presumably should be better. They're older, more advanced, but we'll see they don't necessarily know the answers either. And so,
Get rid of this.
So in all the cases I gave them, and this started out in the abstract, I think it says 25 questions. I boiled it down to 10. There was some repetition. And I gave them a table, or they referenced the table in that handout. And there was a question. In this case, they were asked to do a writing statement. And so, knowing the work that Nathan has done and Carlton has done in terms of writing, and at this point in both classes, we haven't taught them anything. So as far as writing with numbers, this is just kind of a, what do they do if I ask them to write a statement? In this case, comparing the number of freshwater fishing days versus saltwater fishing days. To do that, I have to be able to read the table, find out which numbers. That's the first task. And then the second task is how do I turn that into a statement? And so, unlike the Carlton situation, they talk about, well, should they use the numbers? Could they use the numbers? Why or why didn't they? Here the numbers are right in front of them. They just have to pick the numbers. And so, in this case, what we're looking for is compare 433 to 86. I could have written the statement that way and eliminated the reading of the table. Most but not all students got those two numbers as a starting point. So if you don't get the right numbers, obviously you're on the wrong track to start with. And in the undergrads, 5 out of 13 groups made incorrect statements. And in some cases it was picking the wrong numbers or reporting. In some cases, some people wrote percentages instead of the number, so they compared 85% to 26%. Again, that's not what it asks them to do. And writing is hard, with numbers, and Carlton has found that. What's interesting, though, is when you ask them to compare, even if they pick the wrong numbers, how do they do it? Well, what I call ordinal comparison is, what those 6 people typically did is they said, well, 433 is more than 86. They said freshwater fishing days are more than saltwater days. In those 6, almost half the groups, all they said was A is bigger than C. Yeah.
I don't think I understand the table, because 433 plus 86 is not 517, and 420 plus 18 is not 433.
Not exclusive.
Yeah, you can. It turns out you can do both. So if you're fishing in, along the coastline, you could. Well, actually, this is in a year. So in a given year, I could go to San Diego, do saltwater fishing for 5 days, and I spend 20 days in Minnesota fishing. So you can be in both categories. So it's a tricky table. You know,
And this was groups of like 4 students?
2 students.
2 students?
2 students in a group.
Okay.
So 6 people, or 6 groups, made this ordinal comparison. Just, you know, fresh water is bigger than salt water. It doesn't tell you anything. You know, when I go through the results, I tell them, I say, well, you know, my 5-year-old twins, that's about what the level of comparison that they would make. If I give you, 5 crackers, one of them 5 crackers, the other one 4 crackers, they know a little bit of math, but they know certainly that one got more than the other. And here, you know, they've got the numbers 433 and 86 right in front of them, and you know, all they say is more. And the other 6, or another 6 people or groups, simply said there were 433 freshwater days, 86 saltwater days. They made no comparison. They just wrote, you know, these are the numbers. Didn't make any attempt to compare them. They just took the table, turned it into a sentence, and stated it as a fact. And then one group actually turned it into a ratio and said that there were approximately 5 times the number of freshwater days compared to saltwater days. And so that first one is it's a little bit tricky. It's a different kind of table, but you know, as we go along, you know, here's another table, and I ask them, well, what percentage of Great Lakes anglers fish for perch? The same type of thing. Well, perch is down here. A lot of people like to look at the tables, see a number. The common wrong answer is 2%. Most people chose 2%. You know, the correct answer is that, you know, 500,000 out of 1.4 million were Great Lakes anglers fishing for perch. And just about everybody got that wrong. And they couldn't see that the 2% that the table says is a different 2% than the question was asking. And yet it's important because we talk a little bit in statistical literacy about arguments. I can make 2 different statements that are true. They sound very similar. And so if I want to argue that perch are under pressure in the Great Lakes, I can say, well, 36% of all Great Lakes anglers fish for perch. If I want to say, well, no, we don't want to regulate, you know, perch fishing, I could also say 2% of all U.S. anglers fish the Great Lakes for perch. And it sounds like a very small issue. And so how I frame the, and which percentage I report, you know, both are true, but they may lead you to 2 different conclusions. And so, besides tables, we also look at pie charts, and pie charts are, again, something students learn in elementary, middle school. And with these questions here, they do a relatively good job. They're just reading the pie chart. So what percentage of anglers are less than 35? Just about everybody got those correct. They know how to add slices of the pie together. Which percentage of anglers between 2 age groups, they know how to do that, again, fairly well. If I switch the question, though, what percentage of 18 to 24-year-olds are anglers? We can't tell, and in the form that I handed out, there was a space for the answer, and I also gave them a column where they could circle don't know, can't tell. So that was an option in all these questions. So I wasn't trying to trick them. I told them ahead of time there's this option that you may not be able to tell. Again, 10 out of 13 groups in the undergrad missed that. They gave, typically they went for the 8% that you see on the chart, and the MBAs were too much better. 6 of 11 missed that question. And so, sometimes it's easy to see it's got the same words, but they're in a different order and they mean a different thing. And this one is very similar. And so you may say, well, that was a trick one. I talked a little bit in the class about definitions. So in this thing, they're talking about the percentage of wildlife watchers. And you might wonder, well, what is a wildlife watcher? And so Nathan mentioned about the social construction of statistics. There's a definition. If I go back and read the 168-page report, there's a definition of what a wildlife watcher is and how I have to qualify, because you would think almost everyone in the United States has watched wildlife at some point in their life, so there has to be some operational definition for it. And so the correct answer is you can't tell from reading the graph. That's something you have to go find. And so that one I didn't judge right or wrong. But then I asked them the same question back to back with the different wordings, because before you didn't know because the ages were different. here I said, well, what percentage of 35 to 44-year-olds are wildlife watchers? The answer is can't tell from the chart. What you can tell is what percentage of wildlife watchers are between 35 and 44. Well, here when I had the two questions back to back, I think students realized I can't answer both of these. But then they had a hard time knowing which one was correct. Which one do I put an answer down for, and which one do I put can't tell? And we get just about half of the people at the undergraduate level missing that one in one direction, or actually in both directions, because obviously there's some confusion here as far as how do I interpret the table that's given. And in this same article, then also, along with tables, pie charts, we also talk about bar charts as a skill that students should be able to read. Again, a fairly elementary concept. But if I ask, what percentage of low-income households are wildlife watchers, that one's fairly simple. I can pick that off the table. And if I ask, well, what percentage of those under 35 are wildlife watchers? In this case, the bars represent the percentage of people in that income category that watch. The answer to the first one is 23%. Students can pick that one up pretty easily. They know how to read a bar chart. When it comes to the second one, what most students tried to do was they added the bars. They said 50%. But there's a problem when I start adding all these bars. Eventually I'm going to get over 100%. So it can't be 100% of, or 200% of all all incomes are wildlife watchers. So the correct answer is I can't tell. Only one student made a comment that said, well, at least it's somewhere between 23 and 27, some weighted average between those two numbers. But only one student out of 40 of these saw that, and so the rest fell for the addition of those bars. And this was a bar chart on the back of the survey, and they gave you the total number of bird watchers. Again, 47.7 million Americans are bird watchers according to the survey. Obviously, everyone's seen a bird, so there's an operational definition for what a bird watcher is. And they define bird watching either around the home or away from home. And in this case, we asked, how many bird watchers, that's a number, that participate in both of these activities. Because by their definition, I can be a bird watcher at home. If I feed the birds at home or I take an active interest in birds at home, I'm in that category. I can also, if I go on a trip going birding, that also puts me in the other category. And so this is kind of like a Venn diagram. We're looking for what's the overlap of these two bars. And here, all the undergrads missed it, and most of the MBAs. And a lot of them, at this point, said can't tell, or they, I got a variety of different answers. Some people added the two numbers together, 41 and 19. Obviously that's wrong, but one attempt that you might try to make. And so, these things should be relatively easy. As I said in the slides, this isn't rocket science. We're trying to show them tables, graphs, and pie charts in some context that should be readily accessible to them. I had one example of writing statements including numbers. I do a lot more of that in my class, but this was kind of their introduction into seeing how they do it. And then once we go forward in the class, then we go through, well, how might I have written these statements in the different forms, and different levels of sophistication. And we're interpreting summary data. Even though this is a statistics class where we typically deal with raw data and how do I analyze it, for the statistical literacy for managers course, many managers don't do data analysis. They get the summary financial reports from the accounting department or other places. And so our goal is to help them be able to read and interpret that and communicate with that. And so in the brochure, in the handout, I put a link to the PDF of the brochure if you want to try this out with your class. I also put a link out on Milo's StatLit website that'll have the same handout that you have that has the graphs and the questions. And so what I might encourage you to try is take the survey yourself, see if you can answer the questions. And some people have no problems. Other people, they start looking at these and then they say, well, these are trickier than they look at first. And then also try it out with your students. With 10 questions, it's a relatively short activity, but it sometimes is an eye-opener to see I think the students should have known this coming into my class, and yet they can't read a bar chart or a pie chart or a table and give me the numbers or write comparisons with them. So.
All the data that you showed about the students' answer, is that before or after the course?
That's before. So this is an assessment coming essentially before we teach anything to them. So we oftentimes wonder, well, what knowledge do students come into my class knowing? And so I'm going to teach them about creating bar graphs and pie charts in an Excel-based class. If I assume that they know how to read these things and what they say, really jump ahead of where they're at. And so, if I have to, knowing this, I have to take a step back and say, well, this is how we read a table, this is how we read a pie chart. If this is the difference between a part and a whole, or what the pie represents, what does the slice represent. It's changed the way I've taught the class, because I can't necessarily assume that the students all know that.
But it also seems to me that you're presuming that all your students really understand what a percentage is. So that, if they don't, you're not really assessing their literacy, their ability to read the charts, because they might be able to read the chart, but they might not be able to determine what denominator or numerator is.
And I should, it's a true statement. The one thing though is both the classes I teach are designated as MP3, math placement level 3 at Augsburg. So they've gone through, it's what college algebra is.
One and a half.
Yes. So they've had they've placed above remedial math, so they should know percentages and something. I'll say should, but they have some prerequisites, so they're not coming in straight.
A lot of our algebra students can't do percentages.
Yeah.
It's good to know.
Did you do any post-assessment out there?
Well, I haven't yet. This was work I did in September. We went through and taught it. They're going to have a midterm exam in a couple of weeks, so I'll be able to see how much of it they've retained or learned. So, in a sense, I haven't gotten the post yet, but hopefully, by showing them the pieces they're missing, it should be better.
But the fact that you paired students together and your post test is going to be on an individual basis?
Right. Yeah. It's going to be hard to.
Issues there.
Yeah. Yep. Yeah. When I started this out, it wasn't necessarily my goal to. This was just a classroom activity that kind of fit into this idea of assessing. And so if I would have started back, I would have done it individually at the beginning. But it started out as a classroom activity that kind of grew and morphed as I showed it to more people and the context of this.
Okay, we'll have some more time for questions at the end. Can you shift my presentation, hand this around?
Which one do you want first?
PKAL. I talked to a number of my colleagues at other departments into administering a survey. I looked through the applications here, and a number of institutions are saying we want some way to assess whatever it is we're talking about, quantitative literacy, etc. Assessment isn't easy. It takes a while to build a good assessment instrument. I had done a survey in 2002, learned a lot from that. I put together another survey instrument, 69 questions, which is way too long to administer institutionally, but this is the only way you can find which questions really do the heavy lifting, which ones are the good predictors of student scores. I have copies here. Next slide. What I've argued is that we all know there's a need. You wouldn't be here if you didn't see there was a need. We all know we have to have faculty support. It's got to be accessible. We want to see QL grow. To me, the problem's here in the middle. What are the concepts, the principles, the skills that QL necessitates, requires? We don't have agreement on that. And I would say it's got to be understandable by all faculty. If we're expecting all the faculty to bring this up when it's appropriate in their class, I'm not asking the Chaucer scholar to wedge percentages into their class, but when it's appropriate to be able to handle it. Once we have this, I think we can get QL growth. Otherwise, things like this can just stay at a certain level, and they don't really get traction to move up. I mean, Gen Ed is really the major league. So QL is kind of at the doorstep at this point. So, next slide. 2002, we did a survey, found a lot of problems, got some ideas with this tables and graphs, etc. 2007 and 8, we did surveys of newspaper articles. What is used in the newspaper? How often do percentages come up? Rates, etc. How often do the statistical concepts come up? And that gave us some background as to what things should our students know to handle this medium. Next slide. We administered the 69-question survey. Student scores on the vertical axis ranged from 25 to 75%. So we had a nice variation. That's what you want in an instrument, is that it doesn't wedge students all into either the top end or the bottom end. Next slide. And then by question, you want a variety of questions from easy at the top to difficult at the bottom. So there again, we felt like, well, we had some good things going. Next slide. First, what were the hardest questions? Out of these 69, this was the hardest question the one students were most likely to miss. They're given a table of percentages, and which comparison, given down below here, fits this data? A, women are more likely among whites than blacks. We're not even into the arithmetic part Mark wanted. I'm just into the ordered comparison. They look up here and they see women. 49, 25 women, the white number is bigger than the black number. Well, that's a possibility. Next, blacks are more likely among men than women. Among women. You look up here, blacks, 75. Blacks, 25. Well, this looks like it could be a true statement. So we have C, it's either of the above. D, none of the above. E, don't know. Now you have to think real carefully. For us, context is largely syntax. It's the words that determine the context. So you have to read through this real carefully and say, now, what are the words here? Among. That's pretty much Trump in English. That's what sets up the pie when you're comparing pies. So in this case, we're comparing among the whites, among the blacks. We're going this way, each little pie. In this one, we're saying among the men, among the women. But this chart isn't designed to do both of those. It's got 100% on the right side. We have 4 little pies stacked up here. Correct answer. Slide or hit the space bar. Yeah. Okay. Students came up with, most likely was C. Either one's okay. We can't tell the difference. They're just, you know, in English you can say the same meaning with different words. They couldn't tell the difference between these two statements. And the others after that were a little small B and D. The correct answer is A. The correct answer is A. That these are 100% tables. They're comparing common parts, women, among these two groups. Well, this isn't rocket science, but obviously, if 91% of 100 students are missing this, it's an important item. It really cuts them off from making a comparison. And that's really where you get the power in an argument, is to compare two numbers. Next one. Hard question. 8 is 3 times more than 2. True, false, don't know. Answer is true. What do we get for results? 82% said false. And you can just see how the human mind does it. Joel Best has argued, Milo, give up on this one. The train has left the station. You're back in the dark ages, taking things and trying to interpret them a certain way. I say this means 8 is 3 times 2 more than 2. It's 8 is 6 plus 2. It's a true statement. And maybe that's what our discipline is going to have to do, is just give up on this one, because in peer-reviewed publications, in journals, I see the same error.
Okay, I got that wrong.
Okay.
I don't agree with that.
Okay,
So-
and where it hits is, say we set this one aside, Would we say that 8 is 300% more than 2? Or 200%? Or 400% more than 2? Well, if we say it's 400% more than 2, we have a problem. So this may be in a gray area. I'm happy that I don't need to die on this hill, okay? But we do expect our students to be able to make a percentage comparison, okay? So is it 400% or 300%? Students get into 400% real quickly from 4 times more. So, next one. A medical test with 95% accuracy, and you're among a group of subjects that doesn't involve risky sex practices, etc. How likely, what is your chance of having HIV? What percentage of the positives have HIV? And you were told 95% of the HIVs test positive. Up here, HIV is the pie, positive is a slice. Down here, positive is a pie, HIV is a slice. Okay, and this is what we're interested in when we get results back, or the doctor is. They were given these answers. The answer is less than 95%, way less than 95%, depending on your population. Okay. What did students come up with? Next one. Oh, back up. I guess I didn't show the results on this one. Now, I've been showing some little numbers down here that are going to become important. These are all hard questions, but they're not useful questions for survey design. This is important to know. A useful question is one that helps predict the student's overall score. Next slide compares the percentage okay. Easy questions, the hard questions. And you might say, well, let's just give them all the hard questions and see who survives. On the horizontal axis is a correlation. How did the students score on this question? How did they score on the entire instrument? If we take the entire instrument as being a measure of their overall literacy, quantitative literacy, then we want to pick the questions that have the highest correlation. They do the best job of predicting that score. 69 questions is way more than students can take. It took 45 minutes for some of the students to finish. They get brain dead after 20 with no motivation. This is not an acceptable survey instrument, but you need to give a large instrument in order to identify, out of all these questions, which are the ones that do the best job. So let's turn to some of the questions that do, next one. We have easy versus hard, we talked about that next. What we want are the good predictors, and we want to leave out those that are not statistically significant. And for this sample size, it was up to 0.2. Every one of the hard questions I showed you was statistically insignificant, not useful. Survey assessment design is not an easy process. And we're really trying to go through this to come up with something that's useful. Next slide. Here was one that had a correlation of 0.53. It was the highest correlation in predicting. And you were asked, here's a pie chart. Does this say the percentage of Protestants who are smokers is 40%? You're looking at it, well, Protestants should be the pie and smokers should be the slice. No, smokers is the pie here. So the answer should be, no. 30% missed this. This is not a hard question. But if you missed it, it predicted your score high or low better than any single question in the survey. That's what we're looking for, good predictors. This one, and this came from a journalism survey done at Columbia among the Institute for Research Investigators. Tanker hits a rock, spills out 80,000 gallons, want to convert it to swimming pools. This is just division. 180 divided by 12. And 22% missed this. But isn't it a big percentage? Isn't that? But it predicted. It predicted your overall score very well. If you have problems with arithmetic operations, you're going to go down on a number of things. So each of these are trying to measure perhaps a different facet of literacy. Next one. This gets into something Joel Best talks a lot about, the social construction of statistics and words. Students need to realize that how the category is defined can influence the number. So here, wave deaths. We don't have a generally accepted definition for this. We don't have a organization that does this. But they have to see how the choice of a definition could influence the size of a number. Okay. And they were given A and B, caused by or occurring during. 49% picked B. Okay, that was the majority, but that was a
Plurality.
plurality, but not a majority. Okay, where 28% chose A. You say, really? You know? But in a math class, typically you don't worry about the words. Jane has 3 apples and Jim has 2 apples. How many apples do they have? Get rid of Jane and Jill, get rid of the apples, and add the 3 and 2. Here, the context makes a difference. The wording makes a difference. So you see these results. So this is a kind of question that's important. Yes?
I hate to be picky, but might it not be the case that A is greater than B? I mean, I know that B is all deaths from all causes, but A might refer to deaths that occur after the heat wave has ended.
So the time periods might be different. That's why you can make it.
Yeah.
And that would be it. That's why you need to run these things. That's my concluding point. Thank you, Neil. You need to run these questions and ideas past subject matter experts, because different people are going to pick up different things, and you don't want to have questions that are ambiguous. Okay, next one. I'm going to have to skip over this on the next. Modeling error. There's a whole lot of technical stuff. Skip that, because we've got 2 problems that are bigger. One is sampling error. If we've got 50% on an overall test, what's the margin of error? Because we take this test as being a sample of the student's true score, if you're into item response theory and so forth. This is just a sample. So I ask the student maybe 100 questions, right, wrong, they get 50% right. Well, what's their true score? This is like an inference. What's the margin of error? Well, if it's a 100 question survey, you've got a 10% margin of error. We want a shorter quiz, like 25 questions, the margin of error is going to be 20%. Now, is this acceptable? How do we want to deal with this, et cetera? So there's the model error, a technical subject. There's the sampling error, which is big, and we need to think about the implications of that when you use an instrument for diagnostic or assessment purposes. And then, drum roll, next one. The biggest problem, as far as I'm concerned, is content validity. Who's to say that Milo's choice of 69 questions has any relationship to what anybody else thinks is numeracy, quantitative literacy, etc.? This is where you need to talk to subject matter experts and say, well, what skills do you think are important in being numerate, quantitatively literate, etc.? And after you've gotten that sort of thing, then assessment people can take that information and go away and do assessments. But without that, it's a floating abstraction. So I may be able to whip out a 25-question survey instrument that does certain things. You look at it and say, it doesn't measure anything we're interested in. So I see that as a task for the National Numeracy Network, and I've talked to some people about that. Okay, that's it for, next step, yeah, on down, finish it off. Once we've got an instrument, then we can do the trade-offs between questions and modeling error, that sort of thing, and at the bottom. Then we can really get an assessment of statistical literacy or numeracy, whatever. But it's a difficult process for those of you that have been in assessment and item response theory and so forth. I didn't even go into the heavy item response. There's a full paper on this that's on the web. That's the paper, yeah. 2008 Schield PKAL. It goes through this in 15 pages of mind-numbing detail. What I want to do now, well, questions, comments on this for Neil.
Yeah, I really respect what you're doing, because you're using measurement construction procedures that are standard measurement construction procedures to develop a sound measure. But at least in the literatures with which I'm familiar, content validity or face validity is not highly valued.
Face, true, but there's a difference. Face is what a non-expert would see as being, I think you should be able to do this. Content is usually taken to be among subject matter experts. So I
Yeah,
think that
yeah, but
distinction-
even then, I mean, the emphasis would be on criterion validity. So you have some,
And pick a criterion here. Normally, like, you know, the SAT, we're talking about predicting first year
That's right.
scores.
yeah,
I think we have a problem with a criterion. I agree, if we had a criterion, if we wanted to make it read the newspaper, I could go with it. But even I have some topics that I think students should know that are not in the newspaper. P-value doesn't show up in the newspaper, but maybe this is something a statistician would think they should know. Exponents isn't in the newspaper, but being able to handle 1 over the square root of n might be something that a math person thinks a student should know, or ratio scales. So I'm concerned about picking a criterion. But if you can come up with one, I'm interested. Yes?
Do you consider this to be a formative assessment or a summative assessment?
You can take the same instrument, I think, and use it both ways, depending on the level at which you're using it.
Well, the reason I ask is because you talked about content experts. And my field is chemistry, and when we're developing assessment instruments to probe misconceptions students bring to the classroom, yes, you need content experts to review the all three, face validity and the construct validity and the criterion. But interviewing students to develop the distractors in the first place is considered to be a crucial methodological step, because if you're doing formative exploration of the misconceptions they bring to the classroom, which is a different form of assessment than summative after instruction, those distractors that look good to a content matter expert are usually highly inappropriate to explore the vast territory of misconceptions students bring.
Give you an example of that one. Let's say this is in the format. One of the questions said, last year there were 3 deaths in the city, this year there are 0. What is the percentage change? Answer A was 300%. I never would have thought of that answer in a million years as a subject matter expert. 20% of the respondents went for it. That came from students, because I've been teaching this for 10 years, and so you see what students are doing, and so you can begin to come up with some of the plausible errors and misconceptions. So I think when it gets into certainly the answers, and even in the choice of question, I wouldn't have thought of that question perhaps, as doing a percentage compare. I mean, it's just such a simple arithmetic thing. But that going from 3 to 0 just locked a 3 into the mind and it tossed 100% on. That's going to be the hardest part of this, is really getting that student misconception fleshed out. And if you have some advice on how it's been done well in other disciplines, I'd be very
Usually it's, in my field, it's usually the first thing we do. In other words, we give open-ended questions without any distractors and have the students write open-ended responses, and then there's interviews where you sit down and have them explain and elaborate on their thinking, because you often get much more detail in the verbal explanation than you do in the written. And from there comes the distractors that then get piloted.
Okay, and that's how we started this, with interviews with students a long time ago. In the remaining 5 minutes, I want to turn to a different topic, which is something else that's going on at Augsburg. I'd say it's easiest to introduce quantitative literacy into those majors that have a math requirement. Business has a math requirement. Marc and I are both in the business department. It's easier to work it in there. You've got a course, you can fit it in, the students are expecting some numbers that may be a little different, economics, etc. The hardest place to get an institutional fit is in those majors that don't have a quantitative requirement. And so we took on the idea of putting together a course for students in this area, because we didn't expect the English majors to wedge it into their Chaucer course, etc. So we got a grant for this. What we realized is that the quantitative majors are about 60% of the college grants, but the non-quantitative majors, I don't mean non-quantitative meaning they're non-numerate. I mean they're in majors that don't have a quantitative requirement. That's about 40% of college grants. It's a big number. And it's an important number. These are the people that are going to be our judges, our politicians, maybe our social leaders, political leaders, etc. They may decide the budget for the math division or the sciences, etc. So we felt that it was hard to embed numeracy into their courses. We needed to focus on English. Context was English, because that's the medium they work in. And that the level of literacy mathematically had to be of a graphical level. We've gotten to where we're showing some pretty complex things graphically. They needed to do the things that we talk about, Marc talked about. Next slide. What we've got developed here at Augsburg, let me pass this around. There's a course we've been at for a long time. We've got over 1,000 Moodle exercises because students need a lot of practice on doing some of these little things, and I don't have class time to go over the fact that you don't know a percentage difference. I used to spend class time on that, and you just can't. Colleagues are correct, but a lot of this could be done, and the students agree, this could be done at the 7th and 8th grade levels, some of the stuff we're teaching. It's not being done. I need to get it done, but I don't want to take up class time. So Moodle exercises. We have some web programs that read ordinary English. This is difficult. We want our students, many of whom English is a second language, to be able to take a table, write a comparison, and a web program comes back and gives them feedback on their English grammar. English is not an easy language. There's a lot of ways to say the same things. But we've got programs that read ordinary English. This is a part of what the CAT grant was used to fund. These are on the web. They're open to everybody. And for teachers, we've got these things. Moving on here. What they're doing is working off of newspaper articles where numbers are the focus. Bad statement. The evidence. The focus is on something else. They've got numbers to support this. So ours, like Carlton's, is an argument-based approach. And they need to be able to tell the difference between causative assertions and just associations. Okay? They have a very difficult time distinguishing association from causation. Okay? Next. We use a critical thinking approach. They start with, what's the point of the story? If you don't see the point, and I teach critical thinking, I've taught it for 10 years, undergrad and grad. If you don't see the point of the story, you're kind of clueless about the argument. You can't talk about strength of support. A lot of students have difficulty, even when it's in the title, the first line or the last line of the news article. They just somehow get distracted on things. We have association versus causation. If we have an association, could it be causal? Could A cause B? Could B cause A? Could they both be caused by a third factor, common cause? And at the end, they're going to be making an evaluation of how well the numbers support the point of the argument. This is extremely difficult for students. In a math class, typically you don't do any of this. But I think this is a literacy class. Going on. We've organized the influences on numbers into 4 categories. We have this little acronym, take care. One of the oldest human admonitions, and I think it really applies when you're dealing with numbers. Take care. If the only thing they remember about this course at the end of the day is take care, and that there are these 4 influences you should just kind of tick off, I'd be pretty happy. Starting with the 3rd, I teach a regular statistics course, randomness. That to me is not one of the top 2 categories in this list. Randomness can be there, sample size, etc. Bias can be there. The top 2 are the ones that I consider the biggest values. Context and assembly. Context, what factors are controlled for by the design of the study, whether longitudinal or cross-sectional. The ratios, what things do using ratios rather than counts take into account or control for? When you're making a comparison, what do the comparisons do? If we're using a model, what does that take into account? And finally, what are things that are not in the data, not in the story, that are plausible influences? This is the hypothetical thinking that Marc introduced this term. Really appreciate that. This is thinking outside the box. And for students, math problems never do this. All the information is always given inside the problem. That's not the case with critical thinking. What are the factors that could plausibly influence this they didn't take into account? Why didn't the dog bark type thing? Okay? And finally, assembly. The choice of definitions or mode of presentation. Next one. We have them working with graphs. For those of you that are math people, we're teaching them the difference between a total and a partial derivative without calculus. Okay? This is confounding. And math people aren't surprised that the partial has a different sign than the total. Students are really surprised when the worst hospital in the state is the state university hospital that has the highest death rate. But when you take into account the severity of the patients that are carried in the door, it has maybe the lowest death rate. And they just can't understand how, for everybody, the worst hospital you go to is the university hospital. But if you're in good condition, you should go there. If you're in poor condition, you should go there. They really have trouble with that. We've got a graphical technique where, using data on race, the difference between white and black families, but when you take into account the percentage that are headed by a married couple, go ahead, and we standardize to take into account this difference graphically, go ahead, 2 more. We see the white family income moves down, 1 more, black family moves up, and about 60% of the black-white income gap is explained by family structure. This is important because there are many topics that are almost off limits for us until you can talk about other influences. If we're going to be doing a quantitative course, you need to be able to do this, and you need to be able to do it graphically. So this got written up in Stats Magazine by the American Statistical Association. It's the most innovative thing I see in statistical education in 20 years. My liberal arts students can do these graphs. They're doing weighted averages. There's papers on this in the web too. Need to finish. Let's just cut it off here. The rest is in your handout. If you're interested in looking at a course, we're working on it, and we're partnering. We've done it with Capella, working with the University of Kentucky, with Anderson, getting a couple of institutions that want to try out a course on an interim basis to see how it works at your institution. Questions or comments for either Mark or myself? Yes?
Let's make a comment. I've heard in other contexts complaints that we not set the bar too low, that the level of skill involved is too low. And I think one of the things that Milo said at the beginning of the second section that resonated with our experience here at Carleton is if we define quantitative reasoning to only include the most sophisticated of skills, we will be signaling to those in other divisions that they are not a part of what we're trying to do. Or we will be signaling to them that no, we think they ought to be doing this, but what they ought to be doing is what some of us in the social and hard sciences are doing. And my experience is that is an incredibly offensive message. And so this is a far easier sell for us to try to meet them where they're at and say, well, where maybe that you haven't seen it yet, but where can I envision quantitative reasoning could be relevant to what you're doing? And I see a lot of that in what I'm seeing here, is trying to see how to the English professors and the historians and the religion professors, all right, you're not going to use calculus, you're not going to talk about p-values, but you will want them to be able to read a graph.
I'm half there and half not, because then it becomes a remedial course. I teach a remedial critical thinking course. My students are all assigned to be in my class because they failed the exam. What I like to do is closer to what Neil said on the criterion. I want them to be able to read the newspaper and think intelligently about that. You need all these things that they might call remedial, ratios, tables, pie charts, etc. But you also need to be able to think about the influence of confounders. I have them doing multivariate regression problems. That's a second course in statistics. And we're doing it without calculus, etc. So I say we've got a range of topics, some of which you might
absolutely.
remedial, but some of them which are more advanced than what you're able to teach. Most of the students don't take the second course in statistics. My liberal arts majors are getting that course, multivariate thinking, in a graphical way. So I don't want us to get pigeonholed into being nice, but being remedial. You know,
The range is necessary, but not every professor has to teach everything within the range.
Good point. Yes, sir.
Speaking as an English professor, my question, I have great respect and support for this, but when you speak about English, are you talking about something more along the lines of a composition course? Because you kept referencing Chaucer. And it would seem much more difficult to put something like this into a traditional literature course, unless it's an author, for example, who has like a Thomas Pynchon, for example, was very mathematically based, but this seems more something along the lines of a composition course which focuses upon critical thinking and critical response rather than, again, a traditional literature course.
I hadn't even thought of being able to do that. And there's just so many disciplines, religion, art, music, how is each one going to fit it into an existing course? I felt it's probably going to be an additional course. You just can't wedge it into those courses without doing damage. So this is a standalone course. At Augsburg, it's being recommended by English, religion, etc., for their students to take.
It does seem like a natural fit, though, for a comp course, because comp courses tend to be very loose, very broad in the kinds of materials that they bring in and the kinds of writing and thinking that they have their students do. So that, for a comp, it's not so much wedging it in as it is saying, why don't you bring these kinds of writing resources, looking at papers, into the classroom. So I think it's a much more forgiving area there.
One comment, I made this argument at Nottingham High School, and I was talking to both the math and the English departments, and the English department said, look, we've got this rule above our door. If the sentence has a number in it, it's mass, and we don't deal with it. Not exactly, they said that this way, and the math people said, well, hey, we don't deal with the sentences. We have formulas. So I'm not sure of being able to get widespread acceptance among English teachers to take on another college-wide requirement in their bailiwick. Just might not work. We need to move on to the next session. Thank you for attending. Hope this is helpful to some of you.
So we've got a few minutes until the cluster meeting, so you're in the same room as you were yesterday for the cluster meeting, yesterday afternoon. So